So I brought my final year project, which is an interesting but simple small project. Like I mentioned, the idea is totally self-proposed by myself, and I'm Weiyang from Curtin University, and I'm also the current IEEE student from Curtin University. And my topic is gas to capture with simple sensors. Before that, I need to start with a little bit background. What's the most important part of human's body, you believe? Is the eyes, mouth, brain, or heart? True or all, but I think hands are very important in human's life. And in ancient world, people use hands to make tools and set up fires. Nowadays, they use hands to drive a car, cook dish, and eat with them. And in the digital world, there's billions of people sitting in front of a computer and put hands on the keyboard and mouse. And all this, let's say people use hands to create the world, not going to stop to improve it by hands. So in that point, the actual cognition technology become a hotter and hotter topic. And it is about to let the machine to understand body language in specific hands, sometimes arm and the shoulder. And so people can have a better communication with the machine, tell the machine what are you doing, how you're operating. And almost all the existing application of gas to capture technology application, computer vision and image processing is involved. It's by capturing image or signal from your hand movement and do the image analysis. So the program can tell what are you doing by your hands. However, my project, none of this will be necessary. My project is simple, just use a accelerometer and a gyroscope to track your finger movement. The reason I can use that is because nowadays almost all the analog chips start to transfer to digital chips. And then the resolution, speed, accuracy increase significantly. And at the same time, the size reduced. I remember a few years ago when I played with my Wii toys, they got the accelerometer board inside, it's like a mobile phone size. But now you can have like point size accelerometer, so it's perfectly can be placed on the fingertip or hand somewhere. And so the idea is I use a 3D accelerometer to check finger movement and a gyroscope to assess the accuracy with accelerometer. Sometimes when your finger needs to make some decision, like virtually push the button, so the gyro can tell the angle. The angle difference, so it can tell you're making some decision. And I need a powerful and portable processor to get the signal on the accelerometer, so you don't have to put a desktop on your back. I need some small processor and arm or somewhere. And then a wireless channel, so you can have a wireless communication to the actual machine, the computer. You don't have to connect with cables and line. The current stage is still one finger prototype already done, which is I get one finger moving, working for tracking the one finger moving, but it should be straightforward to expand to 10 finger and other joint parts. So the parts I select is this one here. It looks like huge, but it's a combo board for accelerometer and gyroscope, only 5 cents point size. And the Raspberry Pi is a small Linux machine computer, so I can program on it. But this is just for programming. In the future, I can always design a microprocessor just for the project. And then the XP is I choose for wireless communication. Compared to Bluetooth, it's got lower distance, lower speed, but it's still fast enough, and the advantage is extremely easy to implement and generate the wireless channel, communication channel. All the rest of the media interface I use for a little application to test the accuracy of my program, which is AirPlay piano. Here's how to achieve this. The block diagram shows how to achieve this project is on your fingertips, there's accelerometer and gyroscope, and it will track your fingertip with the reading. On the Raspberry Pi on the processor, it's getting the reading, do the calculation, do the analysis to know how your finger moves, then send the result out wirelessly from the ZigBee channel to the computer that you are operating. Since you don't need to understand the basic calculation for a high school level calculation, which is once you got acceleration values, we can always track the distance and the speed. And of course, it's not real time, but in this case, I got the 1/f sample in each time cycle. So the f is 400 kilometers in maximum. So each time period is very small. So so I can have the distance in each time period. Then I sum them up as the total moving distance. And of course, the finger movement is the square root of square of each axis distance the finger move. Then I can tell you the direction and the distance of this point you move. So if you got the last some parts on a globe, so it can track different joints of your hands, like how this part is moving. Here's I won't be too much, so it's a brief introduction for accelerometer and gyroscope. But ideally, accelerometer obviously give you acceleration reading, gyroscope tell you how much you're rotating, how much angle you're rotating. But in analog sensor, it refers voltage value, so you need to convert with some calculation. And in digital sensor, I'm using as extremely easy. It gives me maximal reading, and I use 2 complement on the scale factor, so now I got the actual gravitation reading. The software output diagram is for the testing program, which is all the start is for initialize the setting. And I got once I got reading, I convert the raw reading to the actual readings and do the analysis, start to track the distance. Then when I test my program, I virtually see I press a key. So I start with the origin point. Then once I press that, the program can tell me how much I move. And I reset this point as the origin. So it always can compare from the last point. So it's also a way to improve the accuracy. And of course, I want to do some airplane piano, so it will send us a meeting notes and meeting interface. So the advantage for gadget control, I think it's a future user control system. Actually, it's not future, but I believe it will be a future major user control system. Just like keyboard, mouse, and the touch screen nowadays. And I got this inspiration from this movie, Minority Report, which is my favorite movie. But in this case, it's use a globe to work on screen. And to compare with some existing gadget control application, the motion use microsensor, camera, light sensor. Also, these non-exist sci-fi application, they got one limitation, which is you have to put your hand towards something, towards some reference, towards some sensors, so which is not actually free your hand. This is my final goal. So when you actually achieve the gadget control, you need to be able to control the device wirelessly to move your hand to controlling everywhere, not having to towards something. Because in most of the time, if you put your hand towards some sensor, you will be already able to put on the keyboard or push some button. So this is not real gadget control. And this is the airplane piano program I already mentioned of almost all of them. So I will skip to the other future application. And like the assembly line, you don't have to stand in front of operation table. You can start to move around your factory like a commander, and you can control your assembly line everywhere. And the smartphone makes more sense, as I said, because if you like use a deep motion camera sensor, that's no point. If you want to turn on the light, you don't. If you can turn on the light, you need to go to the wall to push a switch. Or if you have the camera sensor, you have to put your hand toward the camera sensor. In my case, you just stay everywhere in your house and you can control basically everything. Which is reasonable and really not that hard to implement. So all you need to do is just set everything up and then use the communicating channel on my project. project, maybe Wi-Fi in this case is a better choice. And something like a robot control and a smart drive also will be a good choice. And my father used to, once I taught this project to my dad, who's working in an aerospace company in China, and he got a great idea when Chinese sending astronauts to the space. They start learning that. So astronauts barely they can hang up when the rocket is launching. So in that case, sometimes astronauts need to manually push some button for escape or communication or reset. So inside that case, my project will be perfectly fit. So you can just move a little bit your finger to do all of the operation instead of put your hand up and you already be able to do that. So which transform me to some more idea for help disabled people. So my idea is creativity is unlimited. Capture will be a major system we can use, and we can always think there's so many applications to use this kind of technology. So thanks for attention. Is there any questions?
So did you build the airplane piano?
No, I haven't. I said it's a testing stage, but so far what I left is the airplane piano. I said I use MIDI interface, so I don't need to separate music notes or everything. Just send the results from my gadget capture as a MIDI notes, so it will play the MIDI notes.
So if like one finger, if you track movements on one finger and it represents different commands, could it be possible that if you're using multiple fingers at the same time, that it could conflict with the commands?
Yeah, that's something I didn't mention for the Raspberry Pi or something. I use I2C application. So what I2C gives you is two exactly same thing can attach multiple devices parallel. They all store in the slave address and the working parallel individually. And in this case, they can attach 128 different devices. If you need so we can just go on each finger, which gives you 20 devices. I might need 2 more for somewhere to do the offset to cancel the noise. So, but still it's still enough. And also, like I said, those purposes just for me to program the idea. But if this can be done, so you can always start to find some tiny processor just for this project. You don't have to have a Linux computer to run this project.
I just make a comment. It's not really a question, but I think this is beautifully applicable to people with disabilities or who have limited mobility to be able to experience a lot of things that able-bodied people can do. So I really applaud what you're doing. Thank you.
What sort of power source would they need?
In this case, power source is just portable battery, so plug those portable charger. The Raspberry Pi. Also, Raspberry Pi use 5 volt and 5 volt input and anything above 700 milliamp. And this sensor is just use internal charge. So once you power up the board, it will be powered. So power is not a big problem. Like the mobile phone is so small, and therefore I need to implement the project for itself. So I can have this size battery can work for a long time.
It's fine to use gesture control, but there's got to be some sort of feedback. You can't just wave your fingers around without knowing what they're actually going to do. So have you thought about how you actually are going to get the feedback so that you know what functionality you're going to get by moving the fingers in certain ways?
Like the calculator said so far, by getting the acceleration reading, I can also combine with some noise cancelling. But basically, I got the accurate acceleration reading. Then I can track the distance. So this is like acceleration reading. So it's also giving me a distant reading. So it's also always flashing the distant reading. So I can just write a program to tracking each joint point as a point. So you can imagine that as long as the direction and the distance can be tracking, so and all the point can be tracking. So the gastro movement can be tracking.
You have the gestures, but you have to, there needs to be a translate. You need to know what gestures to make to achieve certain outcomes. So,
so far I'm testing like a piano, you just need to move vertically and press keys. So I just testing once you press this key, how far you move, how many keys apart with, and the gyroscope and also zero axis acceleration reading can tell me if my fingers press on key. Something like that.
The thing he's asking though is how do you train the person to use your equipment so that they get the response they want? So how are you envisaging your people being able to learn from your equipment? Let's say I've got nothing but an arm, I've just got an elbow, and how do I know how far to move my elbow to open the door?
I think it all depends on the program. So this project is giving you a possibility that can achieve that to capture. Then people are creative. So say you can think of thousands of solutions to use it. And, like how to compare. Like so far, when I do the project, I compare 28 degree, which is I test the best angle that you need to compare to make a decision when you press the piano key. But people are different, and how strong you want to, how fast you want to move your arm to open the door, it's all up to you. You can always change. So it's just a program value difference. You change the value, you can achieve different user experience.
Time for one last question if there's one.
Yeah.
It's very exciting technology, and I can't wait till it's in my home and I can do things around the place. So whenever you're ready, you can come around and set that up. But what I wanted to ask is, I'm a very gesture-based speaker. Am I going to be turning carbon on and off as I'm having a conversation? You mentioned noise cancellation. Is there some sort of algorithm that can learn from someone and realise what is a gesture and what isn't? Is that something you put thought into?
You mean the noise cancelling?
Well, the noise cancelling, because I'm waving my hands around now, is there going to be some sort of detection to prevent that from being recognised as a gesture?
As I said, the difference between this project to other projects, I don't have any imaging analyzing. All I need to do is tracking each point. The sensor is a point, and the point can be tracked to tell you which direction you're going and how far you move, how the distance you move. So you can program each joint point as a point. So you can have start to use those in image and analyzing to have a full hands in 3D imaging. And this point you just use acceleration signal, this project signal. So you can also achieve like a 3D hand. So if you can achieve that, then all everything you're asking can be achieved.
Thank you very much. We'll wrap it up there.